All right, hello guys. I'll be talking about what neural networks are. Before getting started, my name is Adrian Flores Aquino, and my YouTube channel is flores.adrian. Before getting started, I want to talk about a little bit about myself, kind of introduce myself in case anyone is watching. Well, my name is Adrian Flores. I'm actually currently a senior at Cal State LA, and I'm actually majoring in computer science. And the reason why I'm actually making these videos is for a class that I'm currently taking, which is CS 4540, also known as Intelligent Agents in Learning Environment. The reason why these videos are being made is just kind of to show my understanding of every week's um, classes, trying to show that I do understand the topics, but also being able to teach anyone who does come across these videos uh, just some new topics in case they've never heard of these things before, or kind of introduce them to what it is, which in this case, I'm be talking about neural networks. So let's get started. So what is a neural network? So a neural network is actually it's a machine learning module, pretty much inspired by the human brain, which is where the it got its name from. And it's pretty much where nodes process data in layers, allowing computers to learn complex patterns, but also being able to make predictions based on the data that's being inputted. So neural networks are actually very good for um, image recognition. So in this example, I'm gonna be talking about how handwritten numbers could actually be identified using a neural network, and but in a way where we would be able to understand it step by step, but most importantly, being able to teach it to be able to understand what the final output would be. So, on the image to the right, that's technically how it would look, the neural network, but I'll be going in detail talking about what each layer means, what everything means, just to get you guys have a good understanding of what it is. So before getting started, I'll be talking about what a neuron is. And well, like I said before, since the since the neural network is actually good for image recognition, uh, well, the main part of it is actually what the neuron does. So the neuron is actually uh, pretty much like a small little node, you could think of it, and it pretty much just contains a value, an integer, which would be from 0 to 1. This is a typo, but it's pretty much from 0.1 to 1.0. And pretty much this consists when doing the image recognition, it would be depending on how big the image is. In this example that I'm using is going to be 28 by 28 pixels. So it's going to be having 28 rows, 28 columns, and each little column in there would actually be containing a neuron, which I'll be talking about in a bit. And talking about the neural networks, as you can see, there are actually four layers here. And you guys might not know what each layer does, so I'll be talking about what it pretty much is. Uh, well, pretty much the neurons are sorted into layers, as you can see the little circles. The first layer would actually be considered the input layer. So in the input layer, like I said before, it's going to be 28 by 28 pixels, which is a total of 784 neurons. So in reality, it wouldn't really be this small, the network. It would actually be much larger since it is about almost 800 neurons, which is, well, we don't really want to draw each individual circle for it, but that's pretty much what the first layer would be. The middle layer would actually be the two hidden layers, which are the middle ones. And this is essentially where the magic pretty much happens in pretty much showing the machine learning algorithm how to analyze the handwritten integers. And pretty much what happens in here is the handwritten integer is actually split into uh pretty much little pieces. So kind of if it's like a nine, it would split it up into like 20 different pieces, and then from there try to connect them um individually and try to see what pattern could be created with those 20 pieces. So you could kind of think of it as each neuron being corresponding to that specific piece that's being broken into. And it's the same for the second one, except instead of the small pieces, it would be much bigger pieces. Instead of 20, it'd be maybe two pieces. And for the last layer right here, it would actually be the output layer, which pretty much just indicates what the final answer would be. So let's say we have the integer 9. After doing all the work, the last neuron right here, it would actually highlight um, it would actually highlight super white, meaning that would be the final answer. So let's talk about a little bit about what input layers are. So they are pretty much used to identify uh, the image, right? So let's say we want to identify the number nine. It would actually be surrounded with neurons, essentially 784 total neurons, since that's how big the image would be, 28 by 28 pixels. And essentially, each neuron would actually hold a value, also known as the grayscale value. So it could be either from 0 to 1, like I said before. And if if the value would be 1, that would indicate that the neuron is activated, or also known as being lit up. So as you can see right here, all of these little white nodes, they're essentially either 1 or close to 1, 0.9, 0.8, very close. But if they're black or very gray, that just means that there's really nothing written there, you know? So the algorithm would actually just focus on the ones that are lit up or have some color to it. And the hidden layers, this is, like I said, where the network starts to understand the patterns. In this sample, there is two hidden layers only. Not saying that every network does only have two layers. It could be more, it could be less, depending how big you want it. But essentially, the first layer would actually only have uh, the nine split amongst, let's say, for example, 20 pieces, right? Every neuron in this layer would actually correspond to that little piece, and then from there, identify which neuron corresponds to what. And the second layer for the hidden layer actually does the same thing, but instead of doing 20 pieces, it would actually only be like two pieces, three pieces. So let's say for like the number nine, there's the little zero, and then there's the little line. It would actually split it onto only two pieces. So, and then just connect it from there and then see what matches to what. And for the output layer, it's actually this last layer. So as you can see, the nine is lit up, right? That would indicate that the final answer would be number nine, which is actually correct because in this example, we're doing the number nine. And then, well, there is one thing to remember, which is actually uh, the connections and the weights. And if you guys don't really know what it is, the connection is actually just happening between the neurons that are going on between the layers. And essentially, each connection would actually have an assigned value, also known as weights. So you can see right here in the image, the neurons that are connecting to the other neuron on the next layer. Each of them is corresponding to a specific weight value, and they're either green or red. So if they're green, that just means they're positive, but if they're red, that means they're negative, which is what we don't want. Um, and this is actually used to determine the pixel pattern for a neuron onto the next layer. And well, we really don't want any value higher than one or less than zero. So to fix this, we would actually have to talk about the sigmoid function, which is actually a much more simpler function to be able to understand the weighted sum for each neuron that was used. Because in reality, it would be a couple thousand um, neurons to be calculating for each one. So we could use a sigmoid function, and this pretty much allows the weighted sums to be pushed between 0 and 1. So as you can see before, the values are from 2, 3, negative 1.5, and that's really what we don't want. We actually just want to set a kind of like a range, which would be essentially 0 to 1, which is why we use it. And similar to linear algebra, we are going to be using the matrix to better understand it. And as you can see, we have the sigmoid, the weights, and then the bias. And if you guys don't really know what the bias is, it's pretty much used to determine how high the weighted sum has to be. So kind of to set like a limit to it. And this essentially will help check how positive the weight sum is. And what you can see right here, we have the weights, the matrices, and then it would actually give us our output. And well, just to let you guys know, there is an alternate version for the sigmoid function, which is also known as the ReLU function, better known as the rectified linear unit. Um, it's much more simpler to teach the machine learning algorithm rather than the sigmoid function, since it is a lot going on when it comes to doing the sigmoid function, so it helps better organize it and essentially much cleaner. Another thing I'll be talking about is the universal approximation theorem. And if you guys don't really know what that is, that pretty much is the theorem actually states that a feed-forward neural network can approximate any continuous function under certain conditions. Sorry. Yeah, so let me talk a little bit about that. So how does it really work? So it pretty much kind of thinks of like a neural network as a function approximator, and the it pretty much states that neural networks can approximate any continuous functions, but in this example, uh, the limit would be from -2 to 4, which is what we want. And essentially, how it works, this first one, the equation would be y equals x cubed minus 3x squared plus 2x plus 5. And we want a better way to find how accurate we could find another solution to it, which is what we could do right here. And it's actually splitting the graph into smaller straight lines. So in here you can see the little red line, the black line, the red line, black. And essentially it is about 10 lines, 10 straight lines that we're splitting it. And this essentially helps us better understand, or pretty much helps us get a more accurate version of this graph. So just one thing to remember is the more straight lines you have, the more accurate it'll be. So right here we only have 10. So using ReLU, when talking about it, pretty much what we're gonna be doing, or what is done to identify a accurate version of it, is being able to add and subtract it from the graph and be able to get the function, aka, well, that's a typo. It's not a parabola, but aka this graph over here, which is what we're gonna be doing. So as you can see, the original graph would be the orange one, which is just going straight. But like I said before, we split it amongst little straight lines, which is actually used to identify a more accurate version of it. And this actually forms a kind of like a linear approximation, which is good to remember. And then, well, essentially, if you do want to get more accurate to identify the graphs, it's better to use the ReLU. This would be the formula, and essentially you would find, so let's say from here to here, the slope is 20, -20, right? Using this formula, you could be adjusting it and or either adding it or subtracting it uh to the original equation, and then the more um different equations you have, you kind of add them. So let's say you have three different equations using this equation, you could add them to the final product. So let's say you made three, right? You add them, all three of them, it'll pretty much, if it's done right or if it's accurate, it would pretty much form the original graph that it has. So that's good to know. Some cons to remember is actually it only works on defined range of inputs. So like I said before, this is only from -2 to 4. And if I was to zoom out, it would actually just will not be accurate at all since it's like going way bigger than what it is. So just remember that. And for functions that are non-continuous, you might need more than one hidden layer. So that's one other thing to remember. Depending how big it is or how large the graph is, you might need more um, layers, or you might have to split it into more, well, like I said before, the straight lines. And that would pretty much consist of week one for the class. And hopefully you guys were able to learn something. You know, although it is a little bit sloppy, it is my first time making a YouTube video in a situation like this. And I hope I could improve myself for the next week and the next 6 months. So hopefully everything goes well. And hopefully you guys like the video. Thank you.